Good morning. This is Sanajaji from EC department. Today we are going to discuss the subject cellular mobile communication, the first unit. Okay. So unit 1, this is about cellular mobile communication. So introduction. Different generations that are in cellular, right? This already you know, walkie-talkies. Regularly we can see those in police traffic persons, right? They use push buttons for talking, and they will release the button for hearing the other person's information. Okay, and the next one is cordless phones. Like in 10 to 15 years back, but I think cordless phones are regularly used at homes also. Okay, within a limited distance we can use this cordless. There is no connection between the transmitter and receiver, physical connection, and there is a wireless communication between these. Okay, so this is the transmitting antenna and receiving antenna parts. Within the limited range we can use the phone, okay, for communication, and it needs charging, regular charging we need, right? And this is the cell phone, which is our present regularly used item, right? Cellular phone. So what is the generation? Okay, so year here mentioned in 1981, Nordic mobile telephone. These are the different types of systems, right? 1982 American mobile phone systems, and 85 and 86 total access communication system in 1985 and 1986 Nordic mobile telephone, and this is explained in the last slide. Okay, right. Second generation. What is the improvement of the phones in the second generation? Okay, so DAMPS, Digital Advanced Mobile Phone Systems. GSM, Global System for Mobile Communication, what we regularly use, right? And GDC, Japanese Digital Cellular, CT2, Cordless Telephone 2, and DECT, Digital European Cordless Telephone. These are the countries which are using this type of second generation cellular mobile systems. Okay, and here we are going with the different types of generations in cellular mobile communication. First one, in the first one what we are having is voice signals only. What we are having, only voice signals. Okay, and analog cellular phones. All the cellular phones are analog in nature. Okay, analog phones only, and NMT and AMPS are the first generation cellular mobile qualities. Next, 2G. I think 15 years back, right? 2G phones came to your hand, right? So 2G phones, all you know about this 2G because of the touch phone, right? Android type of phones we used. Voice and data signals. Here in the first G and 2G, when we compared, data signals are available. What is the difference between voice and data? Voice means our analog voice information, right? What we speak, that is voice, right? And data is depends upon the information, text information, graphical information, or picture oriented information, whatever it may be. We will use see that in the data signals. Okay, and digital fidelity cellular phones. Here comes the generation, digital fidelity is there. Next, GSM, CDMA and TDMA are the techniques that are used in the 2G. When coming to the 2.5G, that is not used by all, but some differences are there in this. We can use enhanced 2G, the features are enhanced in this 2G, higher data rates, Okay, data rates are increased and GPRS and EDGE, right? Next, 3G, voice data and video signals. Here comes the picture in video signals. Okay, up to this only data signals. Here is the video signals and video telephony or internet surfing, internet usage, right? WCDMA and UMTS are the technologies in the 3G. Next, in the 4G, enhanced 3G or interoperability protocols. Interoperability means different types of protocol systems is working together to provide the features, right? Next, high speed and IP based addressing is introduced here. High speed and IP based technology is introduced here. And mobile IP, here mobile IP address is there. Okay, every communication system is having a unique IP address, right? Reasons for developing a cellular mobile telephone system. What are the reasons? There are several reasons for developing a cellular mobile system. First one, limitations of conventional mobile telephone system. The limitations which are in the mobile telephone systems, right? Next, spectrum efficiency consideration. We can use the spectrum efficiently. And the next one is technology feasibility and service offerability. These are the reasons for developing the cellular mobile communication. Next, limitations of conventional mobile telephone system. What is this? Limited service capabilities, poor service performances, and inefficient frequency spectrum utilization. Inefficient frequency spectrum utilization, which is fully done in recent technologies, okay, which is very useful in channel sharing and borrowing techniques like this, right? What is limited service capabilities? What is limited service capabilities? See here, two cell towers are there which are covering these two coverage areas, simply represented with a circle, right? All these are moving vehicles. When we carry the phones, right, in the car or like that vehicles, we will consider as moving, okay? So which means coverage area, handoff and channel segment assignment, which means coverage area. Limited service capabilities means coverage area. The first character is coverage area. It is the most important parameter. Okay, next, handoff mechanism. What is the coverage area means? Simply the area which is covered by that cell site, by its height, or it may be with the power also. Okay, it will be varies. What is handoff? Handoff is the process of continuing a call when the mobile unit is going to another cell site, right? So handoff should be done within a short time. That is the most advantage in the cellular mobile communication, which does that one in a short time is having a feature, okay, more important feature. Next, channel assignment. The channel assignment process should be done in a very clear manner. Okay, if the channel is used for communication, when we dial some number and make a call button, right, when you push a call button, then within fraction of seconds the cell site is assigning the channel for our communication. Okay, so whenever we are communicating, that means there is a channel which carries our information between the two persons, or it may be a conference, whatever it may be. So the channel is used for transmitting or receiving the data, right? These are the drawbacks of conventional mobile telephone system. Okay, so coverage area is very less, handoff mechanism will take more time, which makes the drop calls, okay, and channel assignment is also very, very low. Next one, poor service performances. In the past, a total of 33 channels were allocated to 3 mobile telephone systems. Mobile telephone service, improved mobile telephone services. The large number of subscribers created high blocking probability during busy hours. Here comes the important point. Large number of subscribers. Whenever the signal is good, more number of subscribers will takes that same network to use the feature, right? Use that feature means cell coverage, good cell coverage or signal is good. Okay, so that makes high blocking probability. Okay, that means not able to assign a channel for the customer. Okay, that is a problem. In that busy hours means whenever there is a full traffic. Okay, in that full traffic the network may not be able to assign a channel. Okay, that will called as blocking. Okay, the blocking probability will increases. Next, high capacity systems for mobile telephone was needed. What is this? High capacity systems. High capacity systems means which performs the processing speed or assigning a channel in a fast manner, right? So high capacity systems for mobile telephones were needed. The centers which are having a servers, all these we will call it as servers, right? So the processor should be do this process very fast manner. Okay, so that is needed in the systems. Next, inefficient spectrum utilization. The conventional mobile telephone system does not utilize the spectrum efficiently in the conventional mobile systems. Okay, since each channel can only serve one customer at a time in a whole area. In a whole area, only one customer will be served. See here, number of customers by channel. Conventional systems. In conventional systems, here 53 customers per channel, 37 customers per channel. These are the two types of systems which uses this. Yes, calculate the blocking probability as follows. Use 6 channels with each channel serving 2 different number of customers. The offered load can then be obtained. Here, offered load. What is that offered load means? Carrying work, right? A, offered load, average calling time in minutes, right? Into total customers by 60 minutes for 1 hour. Okay, the units are erlongs. Okay, offering load. For A1 and A2, two different systems. Here 53 and 37 for MJ and MK, and here 1.76 into 53 into 6 by 60. Okay, and this one into 37. Okay, so different erlongs will be done for different systems. Spectrum efficiency considerations. For using the spectrum in an efficient manner, what are the parameters that we will that the system need to consider, right? Limitation of the available radio frequency spectrum. What is the spectrum we are having? Okay, and the limitation in the bandwidth. Okay, basically 3 major approaches to achieve the ideal mobile telephone communication. 3 approaches. First one, SSB, single sideband technique, and frequency reuse. That means using the frequency again and again. Okay, how it is possible we can see in the next unit. Okay, next to spread spectrum technique. These are the 3 techniques. Okay, technology feasibility and services offerability. Computer industry entered a new era. Okay, computer industry. Why we are discussing about computer industry means, see here, microprocessors and microcomputers were used for controlling many complicated features and functions with less power and size than that was possible earlier. When compared to the earlier, because of the microprocessors and microcontroller invention, which will have a more efficient working capabilities, will use more control and fast operations, right? So also LSI technology reduces the size of the mobile transceivers. Receivers sizes are very less. So the whole equipment size is going to very small size, right? Already we are having a hand-on phones, right? Like this. In the earlier days, phone means like this size, right? right? Trunking efficiency. What is it? Trunking efficiency. Cellular radio systems rely on trunking to accommodate a large number of users in a limited radio spectrum. In a limited radio spectrum, okay, accommodating large number of users, we will call it as trunking efficiency. Okay, so how it is possible and what are the parameters, we will see. The concept of trunking allows a large number of users to share the relatively small number of channels in a cell by providing access to each user on demand from a pool of available channels. That means, suppose I am having 50 channels, I means in the cell set we are having 50 channels. On the demand basis only, suppose when a customer calls and the network access that one, if the channels are free, then only it will assign a channel to that customer. Okay, on the demand basis, one channel is assigned to the customer. Okay, like that. So that means whenever there is a demand, then only access will be provided, otherwise no access will be provided. Okay, so by using that type of work, this trunking efficiency is increased. In a trunked radio system, each user is allocated a channel on a per call basis, and upon termination of the call, the previously occupied channel is immediately returned to the pool of available channels. Whenever the customer completed his conversation and makes a termination, then the channel is freed and it is go to the available channels 1. That means one number is increased in the available pool channels. Okay, that means simply assigning channels to all the customers, it's a waste of channel usage, right? Whenever there is a need, we will assign. That means the channel, the cell side will assign a channel. Okay, this is the diagram. See here, cell site 1 and cell site 2, two cell sites are there. Here different lines are going to the switches and processor unit. We will call it as mobile telephone switching office, MTSO, right? So see here, data links which are shown as dotted lines and voice links. Okay, few voice links are there and few data lines are there. When compared to this, voice links are more and data links are very less. Okay, and this circle is coverage area, right? Here voice circuits are connected to the landline telephone networks. That means a connection which is from cellular mobile phones to landline connection. Okay, performance criteria. What is the performance criteria? Okay, see here, we are in cellular mobile communication. What we use is simply voice. So voice quality is the first one, and the service quality. Service quality means whenever we require, then service should come, right? Suppose you are making a call, in a few seconds the channel is assigned, that is a service. Within a short time service should be done, right? That is a good service, we will call it as, right? Next, special features. Okay, different types of special features are there in the cellular mobile communication, that we will go in the next slide. So voice quality is very hard to judge without the subjective test from the user opinions. See here, 5, CM5, excellent, good, fair, poor. These are the feedbacks which are taken from the customers. Okay, after, suppose when you make a WhatsApp call, after termination of the WhatsApp call, it will, in the screen we will something show like that, voice quality, communication quality is good, bad, 5 star, 4 star, like that, right? So that feedback should be given by the users, right? So depending upon the area and the signal strength, okay, and the circumstances, weather features, all these will gives about this quality, service quality, right? Next, three items are specified for service quality. The second parameter here is service quality. Yeah, service quality means the cell site should be in coverage, then only service quality will be good. Required grade of service. Grade of service should be good. Number of dropped calls should be very, very low. The system should serve an area as large as possible. First one, coverage area. Whenever the signal strength is good, wherever you are, that's no matter. Okay, in the cell site, near cell site, the signal strength is good, or out of the range, or like that, it's very poor, no matter. Wherever you are, the signal strength should be good. Then only the network provides a full service to the customers. We think like that, right? So as large as possible, the cell site covers the area, okay, by increasing the height or increasing the transmitted power. Okay, next, illuminating. See here, the transmitting power should have to be very high to illuminate weak spots, or we will call it as holes also. Where there is no signal, we will call it as weak spot or hole, right? With a sufficient reception, a significant added cost factor. Okay, next, the higher the transmitted power, the harder it becomes to control the interference. See here, the higher the transmitted power, if you increase the transmitted power to cover a large area, the harder it becomes to control interference. Interference will be increasing and it is hard to control. Okay, so we need to cover more area. At the same time, we need to control the interference. That means we need to limit the transmitting power also. Okay, that we will study in the second unit. Okay, how it's possible. Okay, number of dropped calls. I already said, right? Number of dropped calls means the network itself terminates the call, or it will not assign a channel. That is, we will call it as dropped call. Okay, dropped call. So the number of dropped calls should be very less, then only the customer satisfies and places in the same network, or some amount of time it will be in the network. Simply we will change the SIM cards now. That's the problem if dropped calls will increases. Special feature. A system would like to provide as many special features as possible. See here, call forwarding. Some numbers will be added as call forwarding. Suppose if my number is not possible to reach, okay, within not in the coverage area, I can make my second number or my parents number or my husband number as the forwarding number. So the communication will be done. Whatever it will convey, communication will be done, right? Next, call waiting option. It's regularly we are using, right? Next, voice stored box. Automation roaming or navigation systems. Automation roaming. Okay, all features we are using regularly, right? No extra cost. This is a special feature all are requiring, right? No extra cost. All these benefits should be provided with no payment, right? Only all are available in 333 or 666 packages. Regularly we are usage, right? Uniqueness of mobile radio environment. Next topic. What are the unique features? Right? The uniqueness of the mobile radio environment is described in the following description. First one, description of mobile radio transmission medium. Description of mobile radio transmission medium. Second one, model of transmission medium. Second, model, right? Next, mobile fading characteristics, direct wave path, line of sight, and obstructive path. These are the three types of paths, okay, that travels the signal, right? In different paths, different strength will be accessed by the mobile unit. Okay, next, noise level in the cellular frequency band, and next one, amplifier noise, right? The first one is description of mobile radio transmission medium. See here, This is the antenna height and this is the distance. Here example, in a the mobile is available in the vehicle, right? Some person is calling in the mobile vehicle, right? See here, from the transmitting antenna to the mobile, there are two signals. First one, direct signal, direct path, and indirect path or reflected signal. Reflected signal. As we know that, right? Suppose I am saying like this. The signal comes here and it is reflected, which is very less strength. When I communicating in like this position, the signal strength is more, right? So direct path and indirect path is having two different strengths. Okay. Description of mobile radio transmission media. The propagation path loss increases. See here, propagation path loss. Propagation means traveling. Okay. So in which way the wave is traveling? Okay. Path loss increases not only with the frequency but also with the distance. Suppose when I am communicating this way, in this short distance, its quality is somewhat good. When I want to call some person which is so far from me, okay, from me, so it needs to use more strength, first one, to reach that point. And the second point is, in between me and the person who I am calling, there is an area which is so clumsy and so many discussions are going on in between in between the distance. Then there is a chance of interference also. Okay, first one, traveling loss will be there, and the second one, interference will be added, or the signal distorted more. Okay, two parameters we need to consider. So the propagation path loss increases not only with the frequency, okay, but also with the distance. Next, the propagation path loss would be 40 dB per decade. This is a measurement, right? This means that 40 dB loss at a signal receiver will be observed by the mobile unit and it moves from 1 to 10 kilometers. Okay. So C directly proportional to R power minus 4 or directly proportional to R power 4, where C is the received carrier power, where at the mobile unit. Okay, at the mobile unit received carrier power. R is the distance measured from the transmitting to the receiver. Transmitting to the receiver means this is the transmitting and here is the receiver. Okay, R is the distance. The difference in power reception at two different distances, R1 and R2. Just now I told you na, from here to here R1 and here to some faraway place, that is R2, right? C2 by C1, different carrier powers equal to R2 by R1 whole power minus 4, and the decibel expression is delta C equal to C2 minus C1 equal to 10 log C2 by C1 equal to 40 log R1 by R1. Here when R2 equal to 2R1, R2 means the second distance, is equal to 2R1. Okay, here is the distance R1, here is the R2. When R2 equal to double times the 2 R1, okay, delta C equal to 12 dB. When R2 equal to 10 R1, 10 times the R1 distance, delta C equal to 40 dB. In a real mobile radio environment, the propagation path loss slope varies. C direction proportional to R power minus gamma. A typical fading signal received while the mobile unit is moving. See here, the mobile unit is moving. What happens? Different fading will be there, right? So signal will be increasing or decreasing, whatever it may be. Okay. Next, model of transmission media. Next point, transmission media. Transmission media means here signal, right? Signal is transmitting. Okay. Media means the area or the path, right? Here is some example. Okay, some hill stations are taken. What happens here? Actually it is a free space, no population is there, so man-made noise is not there, right? Man-made noise is not there, so the signal will travel a long distance, no problem in that. Whenever the antenna places at the top of the hill station, the coverage area is very large. But when the antenna is placed like this points, that means in between the mountains, whenever a low path is there, that means signal will reflect like this. Okay, so reflected signal will come back here only, right? Okay, so signal will be in this place only, no possible of communication. Okay, right? A mobile radio signal R of t can be artificially characterized by two components, M of t and R of t, based on natural phenomena. See here, M of t, local mean, here is the R of t. Mobile fading characteristics. Ray light fading is also called as multipath fading in the mobile radio environment. These multipath waves from irregular wave fading structures. See here, one vehicle means the mobile is within the vehicle only, okay, treat like this. So it is traveling in between a city or like this. So many buildings will be there. The signal should reach this by direct paths or reflected paths also. Whenever it receives direct paths, no problem in that, signal is good. Whenever too many reflections will be there, the signal will not have a proper communication. So automatically the caller itself terminates the call. Okay, so too many reflections or multipath fading is not a good one. Okay, next, delay spread. Delay spread. The signals transmitted from a cell site and arriving at a mobile unit will be form different paths which causes delay. So delay, the signal which follows different paths simply causes the delay, which we will call it as not having proper connection, like that, right? Next, conference bandwidth. Bandwidth in which either the amplitude or the phases of the two received signals have a high degree of similarities. Direct path, line of sight and obstructive paths. See here, we already know about line of sight, right? So viewable parts, suppose I can see this part, so it's a line of sight. Okay, if there is any obstacle in between the first party and the second party, like treat like two antennas, so there is no possible of communication. So line of sight is not possible, so communication is not possible. Okay, okay, so line of sight is there, the communication will be there, proper communication will be there. If I saw like this, so is there any communication? No. Okay, so for two antennas, line of sight should be there, transmitting antenna and receiving antenna, right? See here, H1 and H2 are the two different antenna heights, two antennas with different heights, but line of sight is there and some part of obstacles are there. Okay, see here, line of sight is there, full. Okay, operation of cellular systems. The operation can be divided into four parts and handoff mechanism, right? So what are the four parts means this and a handoff procedure. First one, mobile unit initialization, mobile oriented calls, network oriented calls, call termination and handoff. What is this mobile unit initialization? Whenever I switch on the cell phone, okay, my cell phone itself searches about the signal or nearest cell site. which is nearest to me to give more signal, right? Cell phone itself searches, okay? That is, the receiver scans 21 setup channels which are designated among the 416 channels, right? In 416 channels, 21 setup channels are there. So 21 setup channels will be scanned by the mobile unit, okay? That will called as receiver, right? Selecting the nearest cell site, I already told you, it selects the nearest cell site to take more signal, right? Next, this procedure is a self-location scheme and it is user independent. It's not any dependent parameter, okay? Self-location scheme. Next, mobile oriented call, second one. What is this mobile oriented call? A request for the service is sent on a selecting setup channel obtaining from a self-location scheme, okay? It started by the mobile unit. The cell site receives it and in directional cell site selecting the best directive antenna for the voice channel to use, okay? It selects the best channel, okay, free channel, and allocates it. Next, network oriented call. A landline party dials a mobile unit, from landline. Here itself sells mobile phone, okay? Here the landline party dial a mobile unit number, the telephone company zone from landline, right? The telephone company zone office recognizes that the number is mobile and forwards the call to the MTSO, mobile telephone switching office, okay? That means the first party is a telephone, landline phone, and the second party is a mobile cell phone, right? So call between telephone to cell phone. The MTSO sends a paging message to the certain cell site based on the mobile unit number and the search algorithm where the cellular phone is. That means in which cell site the phone number is available. Searching algorithm will be there, scans to identify the cell site and it will gives to the cell site to make a connection, okay? Next, call termination means we already know whenever there is a communication, after that we will terminate that call. Whenever the call is terminated, that means red button we will press now. So connection will be terminated in both sides and the channel will be free to another connections, okay? Next, handoff procedure. That means the call should be continued whenever the person is moving from one cell site coverage area to another cell site coverage area within a short time. That is the handoff procedure, which is a good one in the all cellular mobile communication, okay? That is a good quality. Next, about the hexagonal shaped cells. See here, 3 different types of shapes are there: hexagonal, circular, and some cloudy shape is there, right? See here, real, and this is ideal case and this is facilities case. That means we means the designers treated that cell site coverage area should like this, okay? But it may like this, okay? But actually is here, okay? We can't say the clouds or the air in the limited area. It may travel from one place to another place without any shape, right? So that is the real one, okay? But in the ideology, if the cell site coverage area is like this, then there is no coverage area or no coverage area word is not there. See here, what happens? Exact coverage area is there, right? Okay, so there is no holes. That means no signal part is available, okay? So entire area is covered with signals, okay? So handoff procedure will takes very less time, okay? So that is the advantage of hexagonal shaped, but the real case is like this, okay? Coverage counter should be circular, coverage అనేది ఎలా ఉండాలి means. Okay, however it is impractical because it provides ambiguous area with either multiple or no coverage. Okay, due to economic reasons the hexagonal has been chosen due to its maximum area coverage. Due to its maximum coverage area, hexagonal is chosen. Okay, engineers draw hexagonal shaped cells on a layout to simplify the planning and design of the cellular systems because it approaches a circular shape that is the ideal power coverage area. Hence, a conventional cellular layout is often defined by a uniform grid or regular hexagonal. Why we will prefer this means it's a design methodology. Okay, whenever we design a circuit, we will treat ideal case, practical case and impractical case. That means if there is any failure, it may like this also, right? So the different types of cases. Next one, analog and digital cellular systems. Cellular telephone systems can be analog or digital. Older cellular systems, AMPS, NMT are analog, and newer systems GSM, CDMA, PCS are digital ones. The audio at the microphone always starts out with the voltage levels that varies continuously over a time. Analog systems, the audio is directly modulated onto a carrier in analog one, directly modulated. Digital systems, the audio is converted to digitalized samples at about 8,000 samples per second. Okay, sampling rate, right? See here, in the first one, NTT, I shown you, right? So Nippon Telegraph and Telephone Corporation given this picture. Okay, see here, SUB, subscriber one. EO means end operator. TC, toll center. DC, district center. RC, regional center. Okay, these are the telephone parts. And here AMC, automobile switching center. MCS, mobile control stations. MBS, mobile base station. And MSS, mobile subscriber station. These are the cellular ones. Okay, so this is the complete diagram. When we know these names, it's easy to understand the communication, how it is going on. Okay, thank you. This is the first unit and we will continue with the second unit in the next videos. Okay, thank you.